Hi, my name is Goh Hui Jia and my matrix number is 202437.
Hi, my name is Quay Pin Yin. My matric number is 202975.
Hello everyone, I'm Jia Yu and my metric number is 202974.
Hi, my name is Tay Kar Jo. My battery number is 196245.
Okay, so this is the first question of SCL. Use Green's theorem to show that integral of y squared x plus x squared dx plus 4x minus 1 dy in a simple closed curve C, where C is formed by vertices 0, 0, 0, 3 and negative 3, 0, oriented counterclockwise is equal to 99/4. So we will use this equation to show the answer. So first, we know that pxy is equal to y squared x plus x squared. And qxy is 4x minus 1. And then we can done for del q over del x and del p over del y. So del p over del y is equal to 2yx, while del q over del x is equal to 4. So now we will draw the vertices out so we can see the region clearly. So this is x-axis and y-axis. So the first point is 0, 0, 0, 3, and negative 3, 0. So we can connect the point. So it's oriented counterclockwise. So the flow will be like this, counterclockwise. And now we can find the equation of these three lines. The first line is x equal to 0. Second line is y equal to x plus 3. And the third line is y equal to 0. So now we can substitute into this equation. So plus x squared dx plus 4x minus 1 dy equal to double integral of r del q over del x, which is 4, minus del p over del y, which is 2yx, dx dy. So from here we can see that the value of x is from negative 3 to 0. So integral x from negative 3 to 0, and then y is from 0 to y equal to x plus 3. So y from 0 to x plus 3, and the equation 4 minus 2yx dy dx as the value of, as we integrate with respect to y first. So we can do the integration. 4y minus 2y squared x over 2, and substitute the value x 0 and x plus 3 dx. So we cancel out the 2, minus 0 dx. So we expand it to become 4x plus 12 minus x cubed minus 6x squared minus 9x dx. So we rearrange it according to the power of x. So negative x cubed minus 6x squared, 4x minus 9x minus 5x plus 12 dx. So we can do the integration negative x4 over 4 minus 6x cubed over 3 minus 5x squared over 2 plus 12x, and from negative 3 to 0. So when we substitute 0 into the equation, we get 0, and we substitute negative 3 over 4 divided by 4, and we simplify this into 2x cubed minus 2x cubed minus 5x squared over 2 plus 12x. So by pressing calculator, we can get the number is negative 99 over 4. And 0 minus negative 99 over 4 is equal to 99 over 4. So it's shown.
For question 2, we need to evaluate the following equation, where C is x squared plus y squared equals to 2 squared, oriented counterclockwise. So we let P equals to yx squared, del P over del y equals to x squared, and Q equals to negative y squared x, and del Q over del x equals to negative y squared. And the diagram for this equation is a circle with a radius of 2. So here's 2, here's negative 2 yx. So we substitute P and Q into the equation. Where Q minus P equals to negative y squared minus x squared dA. And from this diagram, we know that the radius is from 0 to 2, and the theta is 0 to 2 pi, which is a full circle. Hence, the equation become 0 to 2, 0 to 2 pi, and we substitute y equals to r sine theta and x equals to r cos theta, and then we get negative r square sine square theta minus r square cos square theta r dr d theta dr. And then we simplify. Sine square theta plus cos square theta is equals to 1. So we will get negative r squared times with r, we will get negative r cubed dr d theta. So we integrate with respect to, this d theta dr. We'll integrate with respect to theta first. So it will be negative r cubed theta from 0 to 2 pi d theta dr. 0 to we'll get negative 2 pi r cubed dr. And then now we integrate with respect to r. We'll get negative 2 pi r power to 4 over 4 from 0 to 2. And then we substitute 2 and 0, and then we'll get negative 32 over 4 pi minus 0 pi. And negative 30 over 4 we'll get negative 8 pi. So that's all for question 2. Thank you.
Hello everyone, I'm Jia Yu and I'm going to explain question number 3 for the steps to solve this equation, where C is formed by the vertices with this coordinate and it is oriented clockwise. So first of all, we have to draw the region covered by C. It is like this. The first coordinate is 0, 0, and then the second coordinate is 1, 0. Then the third coordinate is 1, 3. So it will make up a triangle, and this is region C. As it is oriented clockwise, so it will be oriented in this way. Then we identify P and Q from this equation. This is P and this is Q. For P, we have to differentiate it with respect to y, as there is no y variable in P, so it will give us 0. For Q, we have to differentiate it with respect to x, so it will give us 2y. And then we will identify the region. For this one, it is y equals to 0. For this line, this is x equal to 1, y. And for this one, we can find it using gradient. Its gradient is 3, and then so this is y equals to 3x. So we can see for x, it covers 0 to 1, and then for y, it covers this line and this line. However, because the question requires us to find the region oriented clockwise, so it should be 1 to 0 and 3x to 0. Okay, now we write the formula of the Green's theorem. The formula is like this. Then we substitute all this into the formula. For x, it is 1 to 0 because it is oriented clockwise. For y, it is 3x to 0. 3x to 0 because it is clockwise, so it is different from the anti-clockwise way. And then we substitute this one. This one is dp over dy is 0. Dy dx. Now we can integrate this equation. We substitute 0 and 3x inside y square. We get 0 minus 9x squared. Then we integrate this again. 0, 1. 0, 1 again. Then we substitute 0 and 1 into negative 3x cubed. So we will get, finally we will get 3. So it's the same with the question. Show that the equation equals to 3. We managed to prove it, so proof. Okay, that's that's all for this question. Thank you.
Now I'm going to solve the question 4 for SCL. Curve C is shown below, and this is the region enclosed by the curve C and formed by the 4 coordinates, and this curve C is positively oriented, which means it is oriented counterclockwise. Okay, we need to evaluate the line integral of this function 6y minus 9x with respect to y, and minus sy minus sq with respect to x. Okay, according to Green theorem, the line integral p dx plus q dy will go to a double integral, which the partial q with respect to x minus the partial p with respect to y over the region D. From the question given, in front of the dx is p function. In front of dy is q function. So we differentiate the function p and q. For the partial q with respect to x, this will equal to negative 9 minus the partial of p with respect to y will equal to negative x. Okay, negative 9 plus x. Now we need to figure out the limit of integration here. We refer back to the curve C. For this line equation, this is s equal to 1, and this is line equation s equal to negative 1. For this line equation is y equal to negative 1. For this line equation, we need to find out n equal to ms plus c. For the gradient n, 4 minus 2 over negative 1, so equal to negative 2 over 2 is negative 1. So the gradient is negative 1, negative x plus 3. So for the limit of x is from negative 1 to 1, and for y is from negative y to negative x plus 3. This is the limit for the integration. I put the y first, negative 1 to upper limit negative x plus 3. And for the limit of x equal to negative 1 to 1, dy dx. Okay, now we can solve the integration. First, we solve the integration with respect to y first. Okay. This negative 9y plus sy. For the limits negative 1 to negative 3 plus negative s plus 3. Okay, and we solve the limits first. Plus sy sorry, it should be solve the upper limits, negative 9 plus x y minus negative 9, the lower limits, plus x negative 1. So now we solve the function here. Solve equal to 30x minus s squared minus 36 dx. Okay, now we can integrate with respect to x. Okay, 30s squared over 2 minus s cubed over 3 minus 36x. And we put the upper limits, 30 over 2 minus 1 over 3 minus 36. We minus the lower limits, negative 30 over 2, negative 1 cube, negative 1 over 3, so it's positive 1 over 3, negative 36, positive 36. So this will equal to negative 179 over 2, over 6, minus 257 over 6 equal to negative 218 over 3. This is the final result. So that's all for the question 4 of SCL. Thank you. For question number 5, use green theorem to verify the area of a disk of radius alpha is alpha square pi.
So first of all, we come up with the equation of the area of the disk, which is A equals to 1 over 2 and the y integral for x dy minus y dx. And then we draw out the region covered by the circle, which is t is the region from 0 to 2 pi.
So next we will let x equal to alpha cos t and y equal to alpha sin t. Then we will do differentiation. Dx over dt equal to negative alpha sin t. And we move the dt to the right hand side, become dx equal to negative alpha sin t dt. And then we will differentiate y with respect to t. So dy dt equal to alpha cos t. And move the dt to the right hand side. So dy equal to alpha cos t dt.
And then we substitute into the original equation. Then we'll get half integration from 0 to 2 pi alpha cos t times with alpha cos t dt minus integration from 0 to 2 pi alpha sin t times with negative alpha sin t dt. And then we'll get half integration from 0 to 2 pi alpha square cos square t plus alpha square sin square t dt. And then we know that cos square t plus sin square t is equals to 1. So we'll get half integration from 0 to 2 pi alpha square dt. We integrate alpha square with respect to t, we'll get alpha square t. And then we substitute 2 pi and 0, we'll get half alpha square 2 pi minus with 0, and the final answer is alpha square pi. So that's all from question 5. Thank you.